In this problem, we have a 10-gram penny is dropped from a building that is 125 meters high. The penny is initially at rest. Approximately how long does it take the penny to hit the ground? Okay, as you can see, I am underlining three important things. You can see that I underlined the height and the penny speed, which is initially at rest. So that means that it has zero velocity. Now they want us to find how long does it take the penny to hit the ground, but be careful. Look at this word approximately. We want to approx something to assume how long it would take from our answer. Let's write down some important things we know. So we know that its initial velocity, which is v naught, is at 0 meters per second because it's not moving. Because if it's dropped from a building and the person is holding it before dropping, that has 0 velocity. And the next thing we know the height, which is going to be delta y, because this is going to be a building, so it's vertical, so it's going to be 125 meters high. That's the second thing we know. The third thing we know is gravity, which is the acceleration, which is 9.8. A equals g, but for this is 9.8 meters per second square. But for me, you could use 10 meters per second square to keep your answers a lot more simpler. The fourth thing we don't know is how long it would take the penny to hit the ground. But as you see, we know three things. If we know three things, we could use one of the kinematics equation. The first equation we could use is v equals v naught plus at. Second equation we could use is delta x equals v naught t plus 1/2 at square. The third equation is v square equals v naught square plus 2a times delta x. Okay, delta x just be delta y, but we're looking for the time. Okay, so the third equation is we're not going to use it. Okay, it's either the first equation or the second, but the second equation has the height. So the first equation we cannot use it because the first equation only has the initial velocity and final, including the acceleration and time, but does not have the height. So we're not going to use the first equation. We're going to use the second equation. So let's just substitute the information we know. For delta x, but for this it's going to be delta y. Okay, because we're focusing on its vertical. It's going to be, let's plug in, it's going to be 125 meters equals v naught t is just going to be 0. Going to be 0 plus 1/2 times, I'm going to use 10. Okay, 10 meters per second squared to keep my calculations a lot more simpler, times t square. When we have this, okay, I'm just going to rewrite 125 meters. 1/2 times time is going to give me 5 times t squared. Divide both sides by 5. We get 25 equals t squared. Take the square root of both sides. Cancel out. We get t equals 5. Okay. When you get to this part, you're going to say, is my answer incorrect? Because looking at my answer choice, I don't see any answer that is 5 seconds. But they want us to approximately say like how long it would take the penny to reach the ground. So our closest answer to our final answer we got here is going to be B, because this is 4.5. Okay, is approximately how close it is to our calculation. We can see that t equals 5, so B is our correct answer.